Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on probability, lecture number 32, in which I will give the recurrence formula of a binomial distribution. Now we will give the recurrence formula or recursion formula for a binomial distribution. Since we know that in binomial distribution the probability for x equal to r is NCR p to the power r q to the power n minus r, where p equal to probability for success in a trial, q equal to probability for failure in a trial, n be the number of trials, r be the number of success trial. This is number one. We may write this as PR probability for random variable x equal to r equal to NCR p to the power r q to the power n minus r. Implies that p 0 for random variable x equal to 0, NC 0, p to the power 0, q to the power n minus 0. NC 0 is 1, p to the power 0 is 1, q to the power n. And this is q to the power n. This is number 2. Now, PR plus 1. This will be NCR plus 1, p to the power r plus 1, q to the power n minus r plus 1. This is number 3. Now, probability for random variable r plus 1 by probability for random variable r, and this will be NCR plus 1, p to the power r plus 1, q to the power n minus r minus 1 by NCR p to the power r q to the power n minus r, and this will be equal to NCR plus 1 means factorial n factorial r plus 1 factorial n minus r minus 1 divided by factorial n factorial r factorial n minus r, and here remains p, here remains q. This equal to factorial n by factorial r plus 1 factorial n minus r minus 1 multiply factorial r factorial n minus r by factorial n, here p by q. Here factorial n cancel. Here factorial r, here factorial r plus 1. So remains r plus 1 here. Here factorial n minus r minus 1. Here factorial n minus r. So here remains n minus r p by q. This equal to n minus r by r plus 1 p by q. Implies that p r plus 1 equal to n minus r by r plus 1 p by q multiply pr. This is the recurrence formula for binomial distribution. This is number 4. Putting r equal to 0 in 4, we get p r means 0. 0 plus 1 equal to n minus 0. 0 plus 1 p by q p0 implies that p1 equal to here n p by q. p0 is q to the power n using 2. And this will be equal to n p q to the power n minus 1. This is number 5. Putting r equal to 1 in 4, we get p r means 1. 1 plus 1 equal to n minus 1. 1 plus 1 p by q. Here p1 implies that p2 equal to n minus 1 by 2 p by q. Here p1 is n p q n minus 1, and this will be equal to n minus 1 by 2 p and p square. Here q to the power n minus 1 means q to the power n minus 2. This is number 6. Putting r equal to 2 in 4, we get p 2 plus 1 equal to n minus 2. 2 plus 1 p by q. Here p2, this is equal to n minus 2 by 3 p by q. p2 is n into n minus 1 by 2 p square q to the power n minus 2 implies that p3 equal to here n minus 1 n minus 2 n minus 1 n minus 2. Here 2 multiply by 3. This means 1 multiply 2 multiply by 3 means factorial 3. And here p square p cube. Here q to the power n minus 2 means q to the power n minus 3. This is number 7. In this way, we may solve and find other values. If here we take PR, here we have in place of R3, and so here 2, here 3, here 3, here n minus 3. Similarly, if we have PR, here n minus 1, n minus 2, n minus 3, dot, n minus under bracket r minus 1, and here factorial r, here p to the power r, here q to the power n minus r. So we get the recurrence formula and use this to solve the problems. Now we solve a problem. Problem is calculate probability of r for r equal to 1, 2, 3, 4, 5 by using recurrence formula of binomial distribution, taking p equal to 1 by 3 and n equal to 5. Here p be the probability for success in a trial and n be the number of trials. Given that p equal to 1 by 3, n equal to 5. Therefore q means probability for failure in a trial is 1 minus p. This is 1 minus 1 by 3. This is 2 by 3. Since recurrence formula of a binomial distribution is PR plus 1 equal to n minus r, r plus 1, p by q, PR. This is number 1. Since we know PR equal to NCR, P to the power R, Q to the power N minus R, implies that P0 equal to NC0, P to the power 0, Q to the power N minus 0. NC0 is 1, P to the power 0 is 1. This is q to the power n, means q to the power n. This is number 2. Since number of trials be 5, n equal to 5. Therefore, putting n equal to 5 in 1, p r plus 1 equal to, here n equal to 5, 5 minus r by r plus 1, and value of p is 1 by 3. Value of q is 2 by 3. Multiply PR implies that PR plus 1 equal to 5 minus r by r plus 1, here 1 by 2 PR. This is number 3. Therefore, putting r equal to 0, we get P0 plus 1 equal to 5 minus 0, 0 plus 1 multiply half P0, and P0 is q to the power n. Here 5 multiply half q to the power n, q is 2 by 3 to the power n means 5. Since P0 equal to q to the power n and q to the power n is 2 by 3, n is 5, implies that P1 is, by calculating we get 0.3292 approximately. Now putting r equal to 1, here P1 plus 1, 2, P2, here 5 minus 1, here 1 plus 1, multiply half, here P1, here 5 minus 1, 4, here 2 multiply to 4, cancel, that is P1. Therefore P2 equal to P1. Therefore P2 equal to P1, which is equal to 0.3292 approximately. Now putting r equal to 2, here P2 plus 1 means P3. Here 5 minus 2, here 2 plus 1, 3, multiply half, here P2. By putting value of P2 is this, and then calculating, we get 0.1646 approximately. Now putting r equal to 3 plus 1, 4, P4. Here 5 minus 3, here 3 plus 1, half P3. Here putting value of P3, we get the value 0.412 approximately. Now putting r equal to 4, P4 plus 1, 5, P5, 5 minus 4, here 4 plus 1, half P4. Here value of P4 is this, and we put this value here and we get the result. So our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.